Hi, this is Discrete 7.2 Notes, Leontief Input-Output Model. Second day. First day, we learned how to do this with a lot of different equations. Now, what's going to happen is that in this section, we're going to use matrices. The matrices are going to make it a lot easier for us to put this together. So from the last section, we had the consumption matrix that we made in 7.1. What this meant was that we had a two-sector economy, batteries and motors, So from the batteries to the batteries, we're going to take 0.03 of the battery production and keep it inside the battery company. Now this number here is a little weird. Well, let's go to this one here. This would be 4% of the motors from the motor company would stay in the motor company. Now this number and this number are a little bit more difficult to calculate because it is based upon battery production for this one and motor production for this one. So what happens actually is that with batteries, I need 8% of the motors from the battery company in batteries. And so what this means right here is that the more motors that I produce, the more batteries I need. So the multiplier on this would be 0.08 times M. That would be how many batteries would come from the battery company over to the motor company. This one right here is how many motors go over to the battery company. Well, 1% of the production of the batteries would be needed in motors to come over here. So this would be 0.01 times B. That's a little bit confusing, but as long as you can get the matrix set up right, then you should be okay. Now, when we do this, we want to set up some different ideas with equations. So external demand, that's our D. So you'll start seeing these things fly around. And that's equal to our total production minus the consumption matrix times the production. So these percentages are going to be working on how much we're going to be producing to keep inside of the company. Now note that C times P is the internal demand. That's the stuff that I need in the battery company and the motor company from each of the respective companies with inside those companies. All right? So then we have a formula here, D is equal to P minus CP. So with this equation, this is going to mean that given P, which is production, what's going to happen is that you want to find D. And remember, D is your outside demand. So if I get an order for a company, then that would be D. If I can produce a certain amount, then that would be your P. So in this case, production is going to be how much your company can produce, and then you can go ahead and find out how much you can send outside the company. That's what's happening here. Now, what happens if we are given demand, which is more likely scenario? Somebody places an order. How much do I have to produce? Well, we manipulate the equation somewhat, and when I do this, I still have P's on both sides, so this doesn't work. So what we're going to have to do is go ahead and find a different formula that will work for this. And so I'm going to do that later on. Well, I guess actually I can do that right now. So what happens is that algebra and matrices are different in how they work. Algebra is a little bit more straightforward. So if I want to go ahead and take this and I want to solve for P. If I want to solve for B in algebra, all I would do is factor this out. So I took out the P, isolated it. Now I can divide by 1 minus C, divide by 1 minus C. So P is equal to D divided by 1 minus C. So here in algebra, when we just have a one sector economy, this is very easy. So production is found by taking the demand, the external demand, and dividing by 1 minus the consumption. Now with matrices, it's a little bit different. Matrices, the order that you do all this in is very important. So if I have this same type of situation, I'm going to write this P minus CP on the left side. So I'm going to factor this out. What happens with matrices is that we don't have a 1. There is no such thing as a 1. What we do, though, have is something that's called the identity matrix. And for a 2 by 2, the identity matrix is just along this diagonal, the 1s. So if you remember your transformation matrices, when we multiplied by this matrix, we got the same picture straight back. That's your identity. So what happens is that when I factor out a P here, P times what matrix gives me back a P. So I take this P and I multiply it by I. And that would be 1 minus C is equal to D. Now I want to solve for this. I can't divide matrices like I can do most other things. So what I have to do then is I have to take the inverse. And when we take the inverse, I actually wrote this the wrong way. I got to write it this way. The order is important. And so here I have this I minus C right here. So what I have to do is to get rid of this, I have to go on the left side and multiply by the inverse. When I take inverses and multiply them by each other, they cancel each other out. This D, and since I did this on the left side, I'll have to do this on the left side here too. And I don't know if you need to know this too much, but for some of you, you get into this, and this is kind of nice to do. When I multiply these two together, the inverse times the function, they just turn into the identity matrix. So the identity matrix times P is just P. And then my final equation is this right here. Okay, so that's the equation that I need. Look at the difference between algebra and matrix algebra. They are a little bit different. That's the basic thing that you need to know out of that. Some of you really get into that. Okay, so now back to our example. Well, we haven't started our example yet. But now if I look at this example, I'm given external demand of 400 batteries and 100 motors. How much will we have to produce in order to make this happen? And then also, how much do we need for internal demand? So given demand, find the production that we'll use. So this equation I can't really use. I'm going to be using this one down here. Okay, so with this, we need to solve for P. Okay, I already did that. So now I have this item set up, 400 and 100. That is going to be my demand matrix. And so when I do this, I'm going to take I minus my consumption matrix. My consumption matrix is right here. And then I got to multiply it by demand. The demand is going to be 400, 100. Sorry, I was off the screen there a little bit, but here it is. So I had an order for 400 batteries and 100 motors. To find the production that I need, I just put this in, and I can put this into my calculator and sort it out. So on the calculator, I just type this in as I can. So this is a 2 by 2. So I need the 2 by 2, 1, 0, 0, 1. That is my identity matrix. And I need to go ahead and subtract my other square matrix, which is the consumption matrix. Now raising this to the -1, as long as it's matrices, that's interpreted to be inverse. So I'm going to raise this to the -1. And when I do this last matrix, this is going to be a column matrix. So this would be 400, 100. And then all I have to do is messed up. So I had a comma there instead of a point. So this is what I get. So what does this mean for us? Well, once again, this is the order that we took. How many batteries do we need to make total? So this would be production. So I need 421 batteries made. and 108 roughly motors made in order to meet this external order that we did get. So how is this interpreted? This is the number that we have to do for production. And then the 21 and the 8, that would be the stuff that we would use internally for this to work. 21 batteries and 8 motors. Now on the second side of the note, if we can produce this much, what we want to do is find out how much we can get for external demand. So we want to make sure that we can meet the needs of our customers. So we're going to use this formula right here. Remember that this is given P, find D. So there's really two formulas that you have here. Production is equal to identity minus C inverse times D, and then the other one would be D is equal to P minus CP. So you just got to make sure that you use each one respectively. This is finding production, this is finding demand. So back to the example, 1,000 batteries and 400 motors. So D is going to be equal to my production. So I already know that. That's going to be 1,000 and 400. And then I'm going to subtract my consumption matrix times my production. So then this one's a little bit more straightforward, and then I can go into my calculator and type this in. So when I do type this in, I get 938 and 374. What do those numbers mean, and does this make sense? Well, once again, this is my production. This is what's available to go outside. Yeah, it makes sense that these numbers are less than my production. And so that's what I end up with. So how we'll answer this. So what does this mean? External demand, I can accommodate 938 batteries, 374 motors. What do these two numbers mean? Oh, that's that, plus that is 1,000. I think I did that right. And 26 plus that makes 400. So this is what we're going to be using internal. So that's my internal demand. Okay, so two formulas. Remember, if I'm given D, find P, and given P, find D. You might want to write that down. There's your homework. I hope you enjoyed this. Thanks.